It's a really nice day out, so I'm out and about in the park. Okay, the problem is that I don't know if someone's gonna try to break into my home or not. I mean, sure, I could order a big fancy system from a major security company, but some of us don't have those resources, and some of us might want to take matters into our own hands, and possibly have such system notify us directly. That's where the Raspberry Pi comes in. Today, I'm going to show you how to develop a security system using a Raspberry Pi. What's up guys, it's AlexRam1313 and today we're going to make a basic door alarm that texts us whenever someone's at the door. A cool feature for security, or a good replacement for like a bell or something. So what we're going to need are the following. First, a Raspberry Pi. I'm using the Raspberry Pi 3 with Rapsian. Next, a magnetic reed switch. Then some resistors, a breadboard, and some jumper wires. A few things to note before we start, however. We need to realize that basically what we're going to make is a simple electronic circuit, with the reed switch essentially relaying a high or low signal depending on magnetic contact. On the Pi side of things, we can send and read these electric signals using these things called General Purpose Input-Output, or GPIO pins, which are essential for communicating with physical devices and, like, Internet of Things stuff. Also, the texting functionality will take advantage of what's called SMS Gateway, where we can email a message to a phone number. Because of this, we're going to have to interact with an SMTP server to send something. So before we continue, make sure to get the proper SMTP information from your email service, and check out this Wikipedia article to find out your SMS gateway address. Let's get started with the hardware aspect to base our code later. When working with GPIO, there are two numbering schemes you could use. BCM, where the numbers are based off the function of each pin, and board, where all the pins are numbered 1 through 40, with the odd numbers being close to the chip, and the even numbers located near the outside of the board. In this video, I'll be using the board scheme. So let's gather components, then connect pin 6, also known as ground, and pin 12 to separate rows on our breadboard. Now connect a resistor to the row linked to pin 12. Then with the reed switch, connect common to ground, then connect the other terminal just before the resistor. I'm using a normally closed switch, which I'll explain right now. Since we're using a normally closed switch in this configuration, we'll receive a low signal, or 0, when the door is closed, and when it's open, we won't necessarily get a 1, but we can use a pull-up resistor to guarantee that. If you're using a normally open reed switch, the signal values will just be flipped. So you'll get a 1 when it's closed and a 0 when it's open. Now let's get to the good stuff, programming. First, let's create a Python module named cred.py, short for credentials, where we'll store the string constants containing your email address, the SMS gateway recipient, and your password. Doing this step doesn't add much to security, but it'll hide your info in the main module. Now onto the main module. Name it doorsms.py or something. First, we need to import all these other modules, including cred. Now let's create a try block and handle keyboard interrupt, which will be raised when a user types Ctrl-C to exit. For now, just type pass. Inside the try block, let's define a few variables. First, need clean to false, which we'll use to clean up our GPIO interface. The next two will be constants. One will be MSG, which will contain something like door was, and the second will be a dictionary named door MSG, mapping true to opened and false to closed. Again, if you're using a normally open switch, just flip the true-false keys. Now let's create an smtplib.smtp object named server using your email provider's details. Then let's start TLS for security, then log in using the credentials listed in cred. Now let's define a function named send_msg with a boolean named open as a parameter, which will eventually run on the side. Inside here, let's compile our message string by taking advantage of the join method with an argument of a list containing msg, the string from the opened index of door msg, at, and finally a formatted time string using time join.strftime. You can read up on formatting later, but I know what you're thinking. Why don't we just concatenate using plus? Well, it turns out join is quicker, and trust me, we need it. Then call server.sendMail, passing in your email address, the recipient's address, and the string we just made. Outside of the function, let's set up GPIO by defining a constant named pin as 12. Set the GPIO mode to the board scheme. Then call GPIO.setup with arguments pin, GPIO.in for input, and pull_up_down equals GPIO.pud_up to enable our pull-up resistor. Next, define nextDate to true, which we'll use to detect a change in the input, then also set need cleaned to true. Now let's write a while true loop to run infinitely, or at least until someone quits. Inside an if statement, type if GPIO.input pin is equal to nextDate. Let's start a new thread that calls send_msg and passes the current value of nextDate in a tuple. Why start a new thread? Well, it sends a text in the background, so it's less likely we miss something in case someone quickly opens and closes a door. Then negate nextDate. Outside of the if statement, call time.sleep for, let's say, 0.3 seconds. This is so we don't overload the Raspberry Pi, and also handle what's called bouncing, where electrical signals can fluctuate when, let's say, the magnet moves closer or farther away from the switch. Then in the accept block, replace pass with GPIO.cleanup, which will free up the pin for other programs in the future. Then set need cleaned to false. At the very bottom, in case there isn't a keyboard exit, if need cleaned is still true, then do the cleanup there. Cool. Now let's try it out. Make sure you have both files in the same folder on the Raspberry Pi, and that you have a phone handy. In the console, change the directory to wherever the files are saved, then type sudo python3 door_sms.py, then push enter. Go ahead and move the free magnet to the connected one, and occasionally check your phone. You should get a bunch of text saying, door was closed at 12 o'clock, or door was opened at 12:01. And there you go. You now have a basic Pi security system. For reference, I'll have a link to the code in the description below. So thanks for watching this video, hope it helps, hope it was interesting, and be sure to like, share, subscribe. See you later.